Alright guys, let's go ahead and go through our Unit 8 study guide. Just a second. Alright, so which of the equations below represents an exponential function? An exponential function is the one where the x is in the place of the power. And so that would be an exponential function. The other two are not exponential functions. Number 2, given that f of x is equal to 5 times 2 to the x power, what's the growth factor? The growth factor is the number that is being raised to a power. So the answer is 2. Number 3, which of the tables below represent exponential functions? You could tell that by observing how the y values are changing. So to get from 3 to 6, and then from 6 to 12, and then from 12 to 24, we have to multiply by 2 each time. Next one, to get from 0 to 1, it's going up by 1, and then it's going up by 3, and then it's going up by 5. You could say that's addition, but there's no multiplication happening there. Next one here, to go from 16 to 4, and then from 4 to 1, and then 4 to 0.25, is multiplying by 1/4 each time. As for this one over here, it's going up by just adding 3. Okay. So, now some of you guys probably were thinking divide by 4 for this one. But just so you know, dividing by 4 is the same thing as multiplying by 1/4. Now the two tables here that are changing by multiplication are exponential functions. You can always find this number here, or in this case this number, by taking your second number and dividing it by your first. So for instance, 6 divided by 3 is 2. Same thing over here. 4 divided by 16, if you reduce that, is 1/4. Okay? And if it kind of works like that all the way through, like 12 divided by 6 is 2, 24 divided by 12 is 2, then that's an exponential function. 4 over 16 is 1/4. 1 over 4 is 1/4. This is a weird one. 0.25 over 1. It is 1/4 though. There's a few ways you could check that. One way is you could multiply the top and bottom by 100 to make it this, and then reduce it. But in any event, the point is that if you could tell you're changing the y values by repeatedly multiplying the same number, that's what makes an exponential function. Things that change by addition or subtraction or something else is not exponential. So for each exponential function identified in number 3, identify the growth factor. So for the first one over here, the growth factor was 2. And for this one over here, the growth factor was 1/4. Okay? Okay, number 5, I mean. What is Euler's number? Well, we use the letter E to represent Euler's number, but I want you guys to be aware that it's approximately 2.71 on your test. You should know that it's just a number. Okay? Let's go ahead and take a look at number 6. The population of a city is 20,000. Every year the population increases 3%. So, part A asks us for the growth rate. The growth rate is your percentage divided by 100, which is 0.03 would be our growth rate. And it's a positive 0.03 because the population is increasing. If it said decreasing, you would make it minus. Part B, write an exponential function to model this scenario. Okay, so when you're writing an exponential function to model this scenario, we have 3 formulas to choose from. I'll write them over here on the side. We have this one. We have this one. and then we have this one. Okay, now you're only going to use, oops, bring that back. You're only going to use this one if you see the word compounded in there, and you're only going to use this one if you see the word continuous in there. Now in this explanation here for number 6, notice there's nothing in there about being compounded or continuous. So we're just using the top formula here to write an equation. And in that top formula there, the A represents the starting amount. The 1 is always there. Plus represents increasing, and minus represents decreasing. And then R is our growth rate that I told you about earlier. So those two things actually just kind of go together, the sign and the growth rate. And then there's an X here and a Y. So in this particular problem, the starting amount is 20,000 people. There's our 1. It's increasing by 0.03, my growth rate. We have that. And it will be simplified to look like this on the test, I guess. So that's the answer to part B. Now the answer to part C says, use your function to determine what the population will be in 5 years. So X, as we saw in part B, represents the number of years, and in this case, X is 5. So I'm going to replace the X with 5. And there you go. Now in class, we actually calculated the answer on a calculator. On this test, you're not going to be using any calculators, so you'll just leave your answer like that, and it's going to be a multiple choice test. You just have to find the correct choice that accurately represents what you would actually plug into the calculator to get the answer. Okay, let's go ahead and take a look at another one. Number 7. Number 7 says there are 1,000 milliliters of water spilled on the hot pavement. Every minute, 15% of the water evaporates. So what's the growth rate? Well, the water's evaporating. That means the water's going away. So it's decreasing by 15%, which means 15 over 100. In other words, negative 0.15. So that's my growth rate. Part B, write an exponential function to model this scenario. Once again, we don't have the word compounded or continuous, so we're using the same one that we had last time to write our equation. So in this case, the starting amount was 1,000 milliliters of water. And then we have 1, and then it's minus because the water is evaporating. 0.15 is my growth rate. And then we're going to go ahead and do the subtraction here, and what we're going to end up with is 0.85 to the x equals y. So that's your answer to part B. Now for part C, use your equation to determine how much water will remain after 10 minutes. We're just going to say, okay, well, 10 minutes represents x. So in my formula that I found in part B, after 10 minutes we would expect there to be that much water. Now we're not, once again, we're not going to actually calculate it. We're just going to leave it just like that. All right, let's go ahead and take a look at number 8. Now notice on number 8 it says compounded. And when you see that, that means you're going to be using the formula that looks like this. Okay, so this is my starting amount here, right? This is my growth rate. The T represents how many years we're looking at. The N goes in 2 spots in this formula, and it's that's the how many times it's being compounded. Now in this case, the problem says that it's being compounded monthly. And when something is compounded monthly, we just have to ask ourselves how many months are in a year, and that would be 12. Okay, so n is 12 in this problem. So if we were to go ahead and go through and set it up, we would have A is equal to 1,000 is my starting amount of money. And my growth rate, 5%. Remember, you're going to do R equals 5 divided by 100, which is 0.05. And it's being compounded monthly, so we put 12 in these two spots here. And then for how many years are we looking at? I'll just put 3 years here because I didn't put it on the worksheet. But before I upload it, I'll try to put that in there. Anyway, there you go. So time goes there. And once again, I'm not going to have you guys actually calculate it. We're just going to leave it just like that. And on your multiple choice test, you'll just find the correct answer that is written in that fashion. Okay. Next one we're looking at here, number 9. So for number 9, it says there is about 1 milligram of moss on a piece of bread if the moss grows at a continuous rate of 10% per day. How much moss will there be in a week? Now there's a key word in here, easy to miss, you don't want to miss it, is this word continuous growth. So when we see that, I want you guys to think of this formula here. Okay? Now on these ones, the P represents once again the starting amount. The plus and minus, once again, represents increase versus decrease. The R represents the growth rate. The T represents time. Okay? So, let's go ahead and see what we can work out here. Okay, so in this problem, our starting amount, it says we have 1 milligram of moss on a piece of bread. Then we write the letter E, that will always be there. It says it's growing, so that means my growth rate is a positive number. You don't need to write plus, but I'm going to just for the visual purpose of it. And a continuous rate of 10%, which for us is going to be written as 0.10. So we have 0.10. And then we're looking at a week now. But not, mind you, this is all about days per day. And so there's 7 days in a week. And once again, all you have to do is find the correct option that has those numbers in place. Okay? All right. Next one we have here, number 10. There are 50 milligrams of ibuprofen in the bloodstream. The body eliminates 48% of the ibuprofen every hour. How much will be in the bloodstream after 5 hours? So once again, notice that there is no word there that says continuous. So we're going to, and it doesn't say compounded either, so we're doing another one of these apparently. And our starting amount is 50. The body is eliminating the ibuprofen, so we're losing 48%. And then this is after 5 hours. And so what we're left with then here would be 0.52 to the 5th power is y. There it is. So for the word problems, you have to decide which formula you're using. If you see the keyword continuous or compounded, you're using one of the special formulas. If you don't, you're using the first one we used and the last one there. And just plugging stuff in, and that's it. All right, let's go ahead and take a look at number 11 here. Let f of x equal that. Find f of 2. So f of 2, that means we're plugging in 2. Got to follow your order of operations. Exponents are first, and then multiplication. So the answer to that one is 48. Next one, find f of 0. So we're plugging in 0. Now, anything to the 0 power equals 1. So in this case, this would equal 1. Last thing we'll do is we'll go ahead and do f of negative 2. Okay, so we know that 4 to the second power is 16, right? But since it's a negative power, it's going to be 1/16. Remember, negative powers make reciprocals. And you can think of this 3 here as 3 over 1 and just multiply straight across, and you end up with 3 over 16. So final answer there is 3 over 16. Okay, next question. So we want to find g of 2. Okay, now when you're squaring a fraction, you just square the top and square the bottom. So 1 squared is 1 and 2 squared is 4. Multiplying straight across, we end up with 2/12, which can be reduced to 1/6. You do want to reduce your fractions if possible. Next one, g of 0. Any number to the 0 power, we said before, was 1. And any number times 1 is just itself. So 2/3 is our answer for that one. Okay, last one for number 12, g of negative 2. Okay, now we saw before that 1/2 to the second power was 1/4, right? But the negative makes it flip over. So instead of being 1/4, it's going to end up being 4 over 1. Multiplying straight across, we end up with 8/3. Okay, now we're going to talk about solving some equations here. So for number 13 through 18, the goal here is you want to get the bases to match. And once you get the bases to match, you're going to go ahead and solve for x. So here we go. So for number 13, I want 64 to match 4. We can do that. I can rewrite 64 as 4 to the third power. Multiply those together. Now the 4 on the right side has an exponent as well. It's a 1. So now we're just going to go and drop off those bases, and what I have left here is 9x equals 1. Dividing both sides by 9, we get 1/9 is our final answer there. So you want to get the bases to match. Number 14. So 27 and 81. In this case, we have to change both of the bases. Both of those numbers can be changed to be a power with a common base. And the common base is 3. 27 is 3 to the third power, and 81 is 3 to the fourth power. Multiplying those, we get the following. And once you get the bases to match and have everything simplified, you go and drop off your bases there, and you're good to go. Let's go ahead and take a look at number 2. Sorry, I don't want to keep screwing up these numbers. Number 15. Notice they already have a common base, so I can drop that off. And I'm left with this. Minus the m on both sides. And we end up with a false statement. And that means no solution. Anytime your m's cancel out, it's either no solution or infinite solutions. If you end up with a false statement, it's no solution. If you end up with a true statement, it's all real numbers or infinite solutions. All right, let's take a look at number 16 here. Both of these bases can be rewritten to have a common base. of 5. So 125 can be rewritten as 5 to the 3rd power, and 25 can be written as 5 squared. Now on the left here, you're going to have to distribute that 3 into both of those terms. So it's going to end up being negative 9b minus 3 on that side. Drop your bases and solve. And there you go. Next one, number 17. Number 17 is kind of a special case. Anytime you have an exponential function and it's equal to 1, you can always rewrite 1 as any base you want to. Just pick the base you want. In this case, we want 3, and give it a power of 0, because any number to the 0 power equals 1. From there, you're just going to drop that off, and you're going to solve what's left. Divide both sides by a negative 3, and you get 0. This one over here, drop the bases off. They're already the same. And in this case, this is exactly the same on both sides. That's when you have infinite solutions. Okay, so there's that. Let's go ahead and all right, so when it comes to graphing, we have some steps we're going to go through. The first thing that you want to do is you want to identify your horizontal asymptote. Then you want to find your y-intercept. And then you got to pick your shape. Okay, so if b is greater than 1, and if b is between 0 and 1, we have one of two things happening. If b is greater than 1, the graph will look like this. If b is between 0 and 1, it will look like this. It's decreasing. And once again, that's all on the basis of whether or not a is positive or negative. If a is negative, everything's the same in this column except it gets flipped over upside down. Same thing over here. And in these problems, this is your A, this is your B, and this is your C. Okay? So for the horizontal asymptote is y equals c. The y-intercept is 0, a plus c. Okay? So let's go ahead and do number 19 here. My horizontal asymptote is negative 2. My y-intercept is 0, a plus c. So that would be negative 2 and negative 2, which is negative 4. And then we have to pick our shape. My b value is between 0 and 1, and my a value is negative. So I'm using a shape like that one there. And there you go. That's that. I'll do just 2 of these problems. I'll let you guys handle the rest. I'll do also some from 23 and 24. Let's take a look at number 20. So for number 20, my horizontal asymptote is 1. My y-intercept is a plus c, which is 0, 6. And my b is greater than 1 and my a is positive, so that would be this shape. Look like that. Okay, let's go ahead and jump down to numbers 23 and 24, and that'll be it for our review. The only difference between 23 and 24 is the fact that they use a weird letter E in there. So in the way that it's going to affect our steps is instead of asking ourselves whether b is greater than 1 or between 0 and 1, the way it's going to, you guys are expected to know is whether or not it's e to the x or if it's 1 over e to the x. But other than that, the problems are exactly the same. So let's take a look at number 23. So for number 23, my horizontal asymptote is -2. My y-intercept is those two numbers put together. So that's 0, -7. And then my shape, since I have an E, we're in this column. And since it's negative, we're in this row, so we're using that shape. And that's that. Okay, I think I'll let you guys go ahead and worry about the rest of those, but hopefully that was helpful to you. And we'll see you guys in class